Hey guys, welcome back to AlgoYogi. We are doing stack series, and the next problem in the list is remove k digits. Let's go to LeetCode and give this problem a read. Given a string num representing a non-negative integer and an integer k, return the smallest possible integer after removing k digits from the integer num. So num is given to us, then there is k, which is also integer, that's given to us. Num is non-negative. We need to remove k digits from our num, and I guess it will be given to us that k is in the range of num's length and 1. So basically we will have enough k to remove from the num, right? So just like you can see in the last example, here you can see the num is 10 and then k is 2. It just removed everything from here and returned 0. Okay, so the problem is really simple. We have to remove k number of digits from our num and then return the smallest possible integer. So that doesn't that definitely says that we can't just remove anything, like any in this case k number of digits and just return anything. Like, it has to be systematic. It has to be wise choices that we make so that the digit turns out to be the smallest. Since our target is to basically make our num smallest possible value after removing k number of digits, then we need to be removing these, in this case 3 digits, from the most significant digit towards the least significant digit. But we have to make a choice that the number that we are deleting has to be greater than the number before it, basically. Since we can make a decision right here, let's say if we were to delete 1, then we will get a number 432219, and if we were to remove the number 4, then we were to get the digit that is actually, let's say if this is 1 remove and then this one is 4 removed, then I should be getting a digit or number 1132219. Now you can definitely say, if you compare these two numbers, then we see that the first number is greater than this number. So removing 4 and not 1 was actually helpful for us to create a smaller number. Now, in order to make that decision, we were comparing that removing, if these are two neighboring numbers, and that too like on the most significant side of this entire number that we have to remove the number that's actually greater, because removing that will actually bring down the value of the entire number. So how do we approach this now in order to remove it? Comparison between the numbers from the most significant digit towards the least significant digits, and then delete the one that's actually greater. So I think the best data structure choice here is stack, to keep track of the numbers from left to right, and we will have basically this check right here while our k is greater than 0 and our stack has some values, and we'll keep a check in the actual code, but let's just compare if a stack's first number is actually greater than or equals to my current number, or I'll just call it let's say num I. If this is the case, that means I will basically pop the number from my stack. And let's go over it. Why? See, so first I see 1, I'll be appending it to my stack. Then I see 4. Now I keep a check, because between these two numbers where I have to delete something, I would rather delete 4. But in this case we will our something that's on the stack, it's smaller than 4, so we will do nothing. I will just append 4 here and then go to the next number, 3. But now you see between these two, what should we keep? We will keep 3 and remove 4. So we will be basically this condition satisfies, and we will be popping 4. And in the end we can just append stack dot pop and append the number, whatever the number, let's say we can call it num I. Okay, that's it. So here we will be appending 3 now. We'll be appending 3, then we go to 2. So between these two, I think it's better to keep 2 and delete 3. But remember, this k is also coming down one by one. So when we delete this 4, then k came down to 2 because initially it's 3, so it came down to 2. Then now I delete 3 because 3 is greater than 2, so I would rather keep a 2 here. So I'll basically append 2 here. Then this 2 comes to 1. That means I only need to remove one more number. And if you see these two right here, then also it doesn't matter which one I remove, but I will actually remove one of these because there could be some other numbers, and we would rather have smaller values than keep some bigger values, like from the most significant sides. So I'll be deleting, I'll be popping. Okay, I'll just pop this 2 and append the next 2, this 2. Then now this k came down to 0. So what I'll do is I'll just keep appending all the numbers. So none of these conditions will satisfy, and append all the numbers. And this is what will be the smallest value that we can obtain. Right? All right. So, but there are other scenarios. There are some edge cases that can happen. What if my number that's given to me is let's say 1 4 5 6 9. If this is the number given to me and my k is 2, in that case this will never satisfy, so I will not be able to pop any number. So what will I do in that case is, in this case you can see that it would be unwise to remove 2 digits from the beginning anywhere. It would be best to delete the last k digits because it's in monotonic increasing order, and the most significant difference that will be made to our digit will be by removing these 2. Because if you remove something from here, that means this number shifts and takes its place, and which is actually greater than 5. So in this case we will make a decision that we remove all of the k number of digits from the end of the number. Okay, so that will be a special condition. We'll just keep a check. If k is still greater, then we keep popping from the stack, or we just remove from the length of the stack. Okay, so I'm gonna switch. Okay, so let's write down our solution. We'll be having our stack that will be storing all the digits that we're going to store from left to right in the num. So for, let's say, digit in num, if k is greater than 0 and stack has something, and stack's top value is actually greater than my current value. I think in the conceptual part I said it needs to be equal, but actually it doesn't have to be equal. Sometimes it's better to delete something bigger after these duplicate values, matching values. So we can't have equal here. So that was a fix. So k equals to 0 and k is greater than 0, and there is stack's value is greater than the digit. At this point you want to pop from the stack that greater value and then decrement your k. Then you want to append anything else to your stack. So stack dot append, you're appending the digit. All right, Now this will basically take care of all the if k is greater, then it's gonna pop those values, and it might have decremented k to 0 and appended everything. Otherwise, let's say if k is still, so I could just do a while here. While k is still greater than 0, then I want to pop from stack, still from the back of the stack, and keep bringing down to 0, because I have to at the end delete k number of digits. I might have deleted some, or maybe I didn't delete all of them, or I didn't delete any. So in that case, the number was kind of increasing, and in an increasing number, we saw in the conceptual part that it's better to delete the digits from the end, because those digits take up the place. If you remove the digits from the beginning, then bigger digits from the end takes their place and make the number even bigger. Finally, let's append all the numbers. Dot join everything in my stack. And there is one more thing. There might be some trailing in the beginning. There might be some zeros that we need to take care of, so we can L strip those numbers. So return res dot L strip L, I think L strip, I think that's the function. So that's used to remove any digits from the beginning. So result will give me, let's say, for example, it was giving me something like 0, 2, 3, 5, and that too as a string. Then using this function, I could just remove all the left occurrences of this, which is 0. If either this should return me something, or this might return me like an empty string. Let's say if it was just 0, in that case I will just have return just 0. Okay, I think let's run it on our example. I'm gonna zoom out. Perfect. Let's submit it. Yes, of course, this has to be while, because we want to keep popping the bigger digits. We had it in conceptual power. If you want to see, like right here, when we wrote the conceptual part, we had while right here, and I just turned it to if. So that's my bad. Now I think this is good. All right, let's write down the time complexity. Time complexity is big of n is the number of digits. Space is also same. All right, this is like a weird problem. Anyway, it's all right. So let's go back to AlgoYogi, mark this solved. See you guys later in the next problem.